Hi, welcome to this video on how to solve Monty Hall using Python. So we're going to solve the three levels. Level 1 is stay, level 2 is switch, and then in level 3 there's a full Monte Carlo simulation using both with a comparison. So let's look first at the code window here for level 1 stay, and what we should do originally is to start with, we should save some variables on the class. So we're going to have a self.current door index. Let's call it x, which could be -1 to begin with. And then we'll also have a round index, which we can also set to -1. So I'm going to use those as I do the levels. So let's start with level 1 stay. Okay, so here we have a solution that will hopefully work. Let's try it out by running code here. So now we should hopefully see 1000 rounds of level 1 here. We can actually see the first 5 rounds play out here in the window, I believe. And then it will fast forward to the end of the animation when we see the last one of the 1000 in total that we're called for. You can see here also how we start to choose the first door, then the second and the third. Then again, we go back to the first, second, and so forth. Now skip to the last 5 rounds. And we see we are at 31%, so slightly below the expected 33%. But yeah, of course, it's very close to 1/3. And here we see the last 1000 going up to 1000 calls or rounds. So we see we achieved 31%, and we also scored 1000 out of 1000. So we basically, we made it. And how is this done? Well, we are using now the current door index and the round index that we had from before. So current door is the one that we choose. So the first time we are called, if you remember, then reveal is set to -1. We haven't made a choice yet, or there is no reveal door. So now what we do is we start off with the door we had before. We increment with 1, and then we do modulo 3. So then we'll always have 0, 1, or 2. We started this one with -1. So first time this will be 0. Modulo 3 is still 0. So we'll start with door A in the first call. And then we just return that door that we chose. And the second time then that we're called, the revealed will be set. So this one will not be used at all. And we just return the same door. And that is exactly the stay strategy. So that's how we solved level 1. And there are, of course, other ways to do it. But let's start to look at level 2, when we are again going to use the round index and the current door index and solve that one to always use the switch strategy instead. So let's do that. Okay, so here we have tried to solve level 2. Let's do run code and see where we got from that one. So it seems we can see already we got 1000 points. And I haven't switched level 2, so we'll stop that. Run again. Yeah, we got 1000 points, and now we're trying to do the switch strategy. So we choose A. If C is revealed, we choose B, and so forth. So here we choose A, B is revealed. No, sorry, I didn't say that correctly. We chose B, C was revealed, and we switched to A. And so forth. So now we're at 80%. We're going to skip to the last 5 rounds. And here we are again below slightly what we should be at, 67%. We are at 64%, but close enough. And then we're going to see the last 5 rounds up until round 1000. So that is the switch strategy. And now we just need to put those two together and do the full Monte Carlo simulation and see results in both columns at the same time in level 3. So let's go to that one. Okay, so here we have tried to solve level 3. And let's switch to level 3 and then press run code. And there we got 2000 out of 2000. Yeah, so we successfully executed level 1 stay for the first 1000 rounds. So I used the round index it started at -1, and then whenever a round starts, then reveal is -1. So we increased to 0 the first time. So from 0 to 999, 1,000 times, we call level 1. And then from 1,000 to 1999, then we call level 2 switch. So here again, we'll see the result for that. Now we're at a perfect 33% on the stay, and we are at 66% on the switch strategy. Let's see where we end up here after 1,000 rounds. And yeah, it's going to be very close to 2/3. And there we are. So yeah, we solved it, and we passed level 3 as well. And we can also see what would be a normal result of the Monty Hall problem done in Monte Carlo fashion. Good luck solving.